Okay, so next one is, now I'm gonna set up gx equal to x squared plus 1. Because we have drawn x squared graph already, so I'm not gonna cover that anymore, but instead I'm gonna introduce a new functions graph. Okay, so this case we can also explore using maybe 5 random x values. So maybe 0, -1, -2, 1, and 2 here. Okay. Now, g -2 means we are plugging -2 into x value, so become -2x squared plus 1. What is the -2 square? Which is 4, so become plus 1 becomes 5, right? So let's find another one. So g -1, then this become -1 squared plus 1, so it become 1 plus 1, so equals 2. So in this case, -2 output can be 5, -1, 2. You do all the similar procedure, then you will get 0, the 1, and 2 and 5 here. Okay, let me plot those points on the plane graph. So, -2 and 5, -1 and 2, 0 and 1, 1 and 2, and 2 and 5 here. If I connect them, become like this, right? So let's go to GeoGebra, and then what is the difference between our original parent function and then gx equal to x squared plus 1. So now we have y equal to x squared graph right here. Yes? Okay. Then now I'm gonna turn it on gx x squared plus 1. So what do you see? So green one indicates fx equal to x squared graph, and orange one indicates x squared plus 1 graph. Looks like this origin moved to 1, shift to 1 to the up, right? So 1 move up, so another vertex point become 0, 1. You see that? Okay. Now next one here. So what about we are finding out hx equal to x squared minus 1. So similarly, we can do exactly the same procedure. So I'm gonna input certain x value, and then we can find its output value. So maybe 0, -1, -2, and 1 and 2 here. You plug -2, then this become -2 squared minus 1. We know -2 squared means 4, so 4 minus 1 become 3. If you plug -1, then becomes -1 squared minus 1. So become 1 minus 1 equal to 0. So the outputs are a little bit different from what we have found from the previous one. So become 3, 0. If you do same procedure, then you will get -1, 0, and 3. Let me plot those points on the plane graph. So -2 and 3, -1 and 0, 0, -1, 1, 0, and 2 and 3. So I connect these points. Then graph looks like this. So go back to GeoGebra again, and then let's find out the difference between hx and then given fx graph. So I'm gonna turn it off gx for a second and then turn on the hx here. Then what do you see? Green one indicates fx equal to x squared. purple one indicates hx equal to x squared minus 1. This vertex point, before it was origin point, now we move down 1 unit, right? So based on this, now we can also conclude one result here. So based on fx equal to x squared, if any function is given, gx equal to x squared plus b, then what does that mean? Yeah, fx move up b units. And then if given hx equal to x squared minus b, then fx move down b units, right? Okay, then now here's one challenge problem. What if I give you maybe ax equal to x minus 1 squared plus 2? Can you conjecture the behavior of this function? In other words, transformation of this function from the fx equal to x squared. So I temporarily delete plus 2 here. So maybe hide it using the highlighter. So let's think we don't have this one. Then you know that this one, fx equal to x squared, will move to 1 unit to the right. Go back here, right? Then b unit to the right. So now we can say this one, 1 unit to the right. And then now I'm gonna just recover this one and instead covering this one temporarily. Then this looks like x squared plus 2. Then can you conjecture how this function transform of fx? Yes, moving 2, right? So before we don't have 2, it was moving 1 unit to the right. Now we temporarily hide this one and then to recover this one. Then we know that fx move up to the 2 units. If you combine them, this whole thing we can conjecture fx move 1 unit to the right, and then move up 2 units. Make sense? Okay, let me clarify whether our conjecture was correct. Okay, so I'm gonna go to GeoGebra and then we'll show this graph. So I'm gonna turn off this one and then another one. So ax equal to x minus 1 squared plus 2. Okay, so what happened? We conjecture the vertex point from its origin here, then it moving 1 to right, move to up here. You see this? Up, right 1, up 2. So our conjecture was correct. Just one more. What if I give you bx x plus 2 squared minus 5? Then now we can say this one move 2 units to the left and down 5, right? So let's try to confirm our answer. So I'm gonna make bx equal to x plus 2 squared and minus 5, right? And then I'm going to turn it off and then just compare our original parent function and this bx function here. As you see, before it was x squared right here. Now it's moving to the left 2 and down 5. Do you see this? Yes. Therefore, you can apply this total 4 property. So 1, 2, and 3, 4 property, and then you can combine together. Okay, then that's actually you can interpret functions, especially the quadratic functions transformation.